So as I mentioned, it's a wonderful pleasure for me to be able to introduce our plenary speaker this morning, Chuck Birkeland. And as I mentioned, Bob and I both had wonderful opportunities overlapping with Chuck at the University of Guam Marine Laboratory. It's a very small faculty out there, and so we all got to know each other very well, and Chuck is just a wonderful colleague. So Chuck got his PhD at the University of Washington with the late Bob Payne, and then in 1970 he went to Strive for 5 years. So he got his first tropical reef experience, and I guess it must have stuck because he's been working on coral reefs ever since. In 1975, he went to the University of Guam Marine Laboratory, and there's a great story about that we were trying to recreate this morning, and I thought I'd just tell it very quickly. At the time that he was hired, he got all of his belongings on the ship and was starting out to Guam, and there was immediately a hiring freeze. And so Professor Roy Suda, the director at the time, who's here in the audience, was very creative and was able to find Chuck the only opening at the University of Guam at that time, and it was in the music department. So we were trying to decide this morning if he was hired as the chair of the music department or the band leader. We weren't quite sure. But for 1 year, before officially moving to the University of Guam Marine Laboratory, Chuck started his career in music. So, and he's, of course, just been an amazing coral reef scientist ever since. He has done very outstanding work on everything from fish and coral recruitment and settlement processes to really trying to understand the life cycle of the crown of thorns starfish. On a very personal note, Chuck was a very wonderful mentor and friend, and my statistical consultant for many years, and so really just a wonderful colleague, as I mentioned. And the students loved him. We have some of his own many of his own students probably here in the audience with us, even though he did teach our biostatistics class and insisted on doing that at 8 a.m. in the morning. So that was a little tough at times. But without further ado, let's bring Chuck up here for his plenary lecture this morning.
Thank you. Thank you very much. And thank you for being here at 8 o'clock, I guess. But I do appreciate you being here. So the theme of this symposium is Bridging Science to Policy, and I'm going to talk about how in the Pacific Islands, especially Palau, the people can be working with the fisheries, not against it, like it's in many places here. The Pacific Islanders, as you know, are close to their resources. They can sense the whole ecosystem from the top of the mountain to the reef, and they get to know the biology of the fishes very well. As Bob Johannes said, the Palauan fisher knew the lunar spawning cycles of several times as many species of fish as had been described in the scientific literature for the entire world. One that particularly struck me, in Yap, I went to this little mom and pop store and saw this calendar that Margie Fallenroe turns out every year. It's kind of an almanac calendar that gives when things are blooming, when things should be planted and stuff. And she mentioned that the women, like this one in the drawing here, they manage the resources and land. They manage their taro, and they take one big taro and plant 4 little ones, and they can manage the livestock, the pigs and the chickens. But in the ocean, there's too much uncertainty. You can't manage fish spawning or whether they got a good recruitment this year. You can't manage that, so people got to manage themselves. And then that was said by a naturalist in Yap. But then Robert May, who got his PhD in theoretical physics, and he's at Oxford and associated with Princeton and Harvard, and his scientific colleagues say pretty much the same thing, that it's just too uncertain in the ocean, so you've got to set up a system that's self-correcting and control yourself. Well, that was, by the way, the conclusion of 33 pages of math. They came that Well, after 33 pages, they say the same thing Margie Fallon-Ruth said. It's just too uncertain. We don't need more numbers. We need to let the system manage itself. But that's kind of, you say self-correcting. That's not very clear. And I'm sort of surprised because he's a physicist. I would think it's clearer to say negative feedback. That would be something like when the stock increases, the population production decreases, and when the stock decreases, the population production increases. They work against each other, and it helps dampen the system. Now, you're all familiar with this, but when you look at this part, this is what's happening. You get negative feedback, and when the stock is increasing, you see it sloping off here, and this is repeated down here. This axis is just the stock on this side, and it's increasing all through here. But this is the rate of growth, and as you can see, it increases up to this point of inflection, and then it decreases. And this is an important point of inflection because at the top, it's negative feedback, which means it's dampened and it's very stable and controlled. When you get down in this part, that's positive feedback, whether you're increasing or decreasing. If you increase the stock, you're increasing the production, and if you decrease the stock, you decrease the production. So they're working together, and that increases the amplitude or rate, and things get out of control, or potentially get out of control. So if you're going to work with the system, you got to keep the fish up here. And I think maybe that's what Margie and Robert May were saying. You've got to keep the fish up here, the stock. Now, Joan Roughgarden and Fraser Smith took this much more specifically. And I've kind of messed it up here because I sort of say this is kind of a cloud. It's not a point, and so I made that as a cloud, and that's why it looks kind of silly. But drawing this line across here, when you take the amount you want to take is basically what the production is, so you leave the system the same, and your change in number with respect to time adds up to what you want to be your take. Well, that's the same on either way. So if you take something here, you get the same as you take there. But of course, the big difference is if you take from here, you're working with the system because when you take it out, you're increasing production rate. Over here, you're working against the system, again, as I said before, because if you take it out, you're decreasing the production. Now, I put it up here because this is very high rate of production, but Roughgarden and Smith said it should be down here at about 75% of the way to K, because if you get up here, you're getting too close to that point of inflection. And it's called maximum sustainable yield, but it's not really that important what this is. The main thing is that's where you switch from working with to against the system. Now, they say it's safer here because this is more productive, but this is safer, and you don't want to go down here because that's less productive. So they say about 75% of the way to K. But this is all mathematical. You're not going out and fishing and saying 75% of the way. And there's another very important point. But first, I'll mention, before I get to the important point, that I looked at this review of overfishing, and there was 117 definitions of overfishing, and a lot of them were just words, but those that were quantitative put it over here, like the Magnuson-Stevens Act put it over here, and that's working against the system. So why is that? Well, I think Palau has a policy that Magnuson-Stevens Act can't deal with, and we'll get to that later, but I'll tell you and I think you know what it is, but the Magnuson-Stevens Act is why not take the same amount here rather than here, because this is very stable. But the problem is it's a big open area. You can't just take from here. The tragedy of the commons or the gold rush is going to make it go here. That's the problem. You cannot manage a fishery that's in a big open area where everybody can go. It's going to go to this side, which is bad. Another thing is that this is all very quantitative. This is all in terms of biomass and the change in number with respect to time, and we can't deal with that. But it is something we can deal with. This is actually different from this, even though it's the same biomass, because these might be the smaller fish on the average, and these are the big fish. That's even worse than the instability on this side. Oh, I love Roughgarden and Smith's analogy. To keep fish on this side of this inflection point is like trying to keep a marble on top of a bowl. It's just not possible. If this is going to be unstable and bad, and that's what's the problem with the world's fisheries. On this side, it's going to be very stable because you're working with the system and you're increasing production every time you take something, and that's like having a marble in a regular place bowl. It's going up, it's going to come back down, and they say even on a rocking ship you can have it and it's going to work. So they were real enthusiastic about it. Now, the problem with biomass as a metric, it's a very good metric for measuring whether things are getting better or they're getting down. It's a quantitative measure of whether things are increasing or decreasing, and it's a good way to compare things, but it doesn't say much about whether the system is in good shape or not. You look at this, you have to measure to say, what's the biomass? It might be okay. You might have pretty good biomass there, but where are the big fish? That's the question. And actually, Peter Hook, a couple of years ago, had 12 years of data from the Marianas Islands, about 4 islands with multiple sites monitored over the years. And in those 12 years, the first few years were before there was 2 years of real disturbance. There was a crown of thorns outbreak and 2 typhoons, so it really messed things up, and then there was a recovery. So he looked at what was recovery and found out that the biomass came back, but that didn't have any predictive value on whether the recovery was going to happen. What did have predictive value was whether the big individuals of the fish were there. Not the biomass, but the big individuals. And then Tim McClanahan wrote a paper in MEPS about these marine protected areas in Kenya, and he found the same thing, that biomass came back in 15 or 20 years, but the functional reef didn't come back till at least twice that long. And he and Nick Graham just came out with another paper I got last night, and I haven't read it, but I saw the abstract. It says the same thing, that biomass does not predict. It just measures whether it's coming or going. But the big fish, that predicts, and that's what you need. And just, I apologize because you can't read this. This is just my notes. I don't like to carry notes, and so I put them there. But the Shea et al. At Scripps, there's about 50 years of fisheries data said that when you start fishing, you can you cause variability in recruitment that's much greater than it would be before you started fishing. But the fish might not be noticeably different in how many there are there or the biomass. But what is different is that you've truncated, which is a real fancy word of saying you took the big ones. But you're not going to see the effect on, I'm saying even before you see any effect on number or biomass, the fact that the big ones are gone is what matters. And then Anderson et al., in similar kind of study, said it's premature to start harvesting if the stock is recovered in biomass. This reminds me of Terry Doan, back in 1992, noticed that after Crown of Thorns outbreak, and this is I'm analogizing coral cover with biomass of fish. Coral cover measures whether things are coming or going, but it doesn't measure how the reef is. But he noticed that after Crown of Thorns, some people report that the coral can recover very quickly, about 10 years, like in Samoa and Guam and Okinawa. It came back after 10 years. Other people like him say it takes a lot longer. But he noticed the real difference is the people who said it's coming back fast were seeing whether the living coral cover was measurably returned. Those who were worried it takes longer were saying things like the size distribution and the topographic complexity of the coral. So I think they're kind of analogous. One's a measurement, but it's not a predictor. Terry Doan had a favorite computer program to estimate recovery for size distribution, and you see that takes more than 10 years. Anyway, Johannes noted that the fishermen, you know that comment I made that fishermen are very wise. They know their fish very well. And then I get these back remarks, well, they want to know a lot about fish so they can catch them, not that they want to protect them. Well, I'll give to that, but this fact that they came forth to the government said, hey, our spawning aggregations are going down. They like to catch fish, but they like to catch fish sustainably. And that's a big difference, as I'll show you later with Western fisheries. Another thing that's good about seeing whether the spawning aggregations are there or seeing whether the big fish are there is you can go down and you say, hey, we got a problem. Whereas if you're going by biomass or coral cover, you've got to go out and measure. It takes too much time. So Bob Johannes said these things, we just don't have the time to do that, and we've got to act fast. I think in the Caribbean was very different than Palau and spawning aggregations. I read for a couple decades about the spawning aggregations going down in the Caribbean, and I think about 60% were gone before there was much action taken. And another, I got a lot of Bob Johannes on this talk. It says, this is the conclusion of a book he wrote on marine pollution on coral reefs, that the main problem is we've got to measure everything in detail and go through all sorts of steps before we do anything, and it's better to act first. Now, why am I talking about size of fish being important? Well, I think it was about 1992, Jim Bonesack pointed out that a 12.5 kilogram, 61 centimeter lutejanid is as fecund as 212 or 233 kilograms of medium-sized fish. So this shows why if you go fishing and you take, let's say, 50 kilograms of this, you're not having much effect. But if you take 50 kilograms of the big ones, which we always seem to do, you're going to have a major effect. There's more than just fecundity involved in this. There's a whole list of things that it's pretty much in the press all for the last 10, 15 years, like longer spawning seasons, the big ones, that's bed hedging for bad conditions, that the little ones don't have that bed hedging as much. And as you all know, it's also, here's Hanauma Bay, and that's a good place if you want to see big parrotfish on Oahu. You can't go very much else to see big parrotfish in Oahu except in inaccessible places. But you see, the algae is really trimmed down pretty well. And then over, I think Russell Sparks, it should have, I'm sure I had his name on this. This is Russell Sparks' picture here. I don't know why it's not showing. But anyway, in western Maui, they got a lot of little parrotfish. And I think he mentioned seminar yesterday, there's no big parrotfish. Now, I'm not saying grazing is the only thing that caused that, but I'm saying that it's pretty well documented by a number of papers that parrotfish less than 20 centimeters don't amount to much, kind of like with the picture of Jim Bonesack's back there. You can have an awful lot of little parrotfish, and they don't do that much good, like in western Maui. Now, I want to say, when I started thinking about this subject, I was kind of hoping that the good policies in Palau came from a grassroots built from their culture, and they got a good culture, and their knowledge when they got a lot of knowledge, but it wasn't. I have to say it was because of, definitely, I saw it myself, leadership. Noah Ida Ong and President Remengesau and Minister Singabao, and now good scientist Yimnang Golbu and Stephen Victor are a major thing that made Palau's policy, and it just didn't come up by itself. And one of the best things they did is when they became a nation, right at the beginning of their constitution, they say each state, which is a small area, I think in about 16 of them, each state shall have exclusive ownership of all living and non-living resources except pelagic fish, which makes sense, from land to 12 miles from their beach. And this is the difference of why Palau has good policy and Magnuson-Stevens Act is working under bad conditions. I'd like to say why this is good. Samoa also has village control over resources, and Allison Green and I were in Palau doing a survey of a marine sanctuary when we happened to be lucky. For the past 3 years, there had been commercial fishermen who went scuba diving with spear guns and with night lights, and they terribly overfished all of a sudden the fish population, the parrotfish population. Parrotfish population was good as far back as recorded up till 1994, and when they started taking them. The local people had a public hearing that Alice and I went to, and they were very eloquent. Actually, you know, the Samoans have their speaking chief and their administrative chief. Well, I can see it's like almost like Shakespeare there. They were very eloquent, and the governor was there. And there were 2 nights when they said, we can't catch the parrotfish like we used to. The commercial fishermen are fishing it down. So the next morning, and this is the way it should be done, the governor put a moratorium on any scuba with night lights fishing. And so his approach was, let's not study it. Let's just stop it, and then we will just study it. But we don't study it first. And this was really good. And as you agree, obviously. And this is why village control is good, because you don't have to get everything wrapped up in making the biology fit the legal and political framework. You're making the framework of action fit the biology. And also, the next thing that happened, and this is the fishermen went off in a huff, and they went over to independent Samoa. Well, within a week or few weeks, about 9 villages there set their own bull, or that's a Palauan, a moratorium on it, and they petitioned the governor to make it a law. But it didn't have to wait for the governor. The villages made it a moratorium, no spearfishing with scuba. They like scuba and they like spearfishing, but don't put them together. Well, let me take an exact opposite. Guam has been very Americanized. Guam was first settled, or at least visited, in 1521, before any other of the Pacific Islands by Magellan. But it's had a long time under Western influence. And Jerry Davis, who worked for, I think he was the head of the Division of Aquatic and Wildlife Resources, was trying to get these marine park areas, marine reserves. And it took him, because everything had to be done through the legal and political means, and he worked hard at it. He needs some kind of an award, because he spent 15 years of his life working these legal and political frameworks, very different than Samoa and Palau. And during this 15 years, only 12 of them are here, because this is from before the reserve, but this is the only picture I could get from the reports. But it dropped, the fisheries catch, the total catch and the total yield dropped by 78%. Or one of them 78, the other 76 or something. But during this is very different, that you're trying to fit things. On an aside, I might also mention that in the West, we divide our land according to legal boundaries, where the Pacific Islanders also have their biological sense that a lot of, in Hawaii, you have the hupua'a, you have things arranged that you have extended families or groups that keep custody of watersheds. And actually in Palau, Minister Singabao, and I think being Noah Ida-ong and Stephen Victor also involved, are getting communities to manage their watersheds. It's called the Babeldop Watershed Alliance. And all around Babeldop, each of these watersheds are managed by a local community. Another thing I really recommend if you want to learn about life in Palau, these 2 books by Ann Keatalong are only about $30 each. You can get them from Amazon, but they tell all the details about how they go fishing, how they manage their resources. And in this, she also told about how the women in village work together to adjust for the rising sea level, adjust their taro patches. But they also told how they redo their watershed and taro patches and stuff. It's a good book, so it got some of these pictures from her. But anyway, the women go out, and it's interesting, they have ways like in the mud where you can't see the clams, they feel with their toes and get them that way. But over the last 30-some years, they've been harvested. Ann Keetalong has been there about 35 years, on and off, but they go out hunting sea cucumbers. And she mentions in her book that over the 30 years, they have to keep going farther and farther for sea cucumbers and crabs, and the men have to go farther for the fishes. But they get their sea cucumbers. But then in 1988, a commercial sea cucumber system was set up, and they started collecting because they sell for a big price in China. And the women then said, we just can't get our sea cucumbers anymore, and they put a bull, or asked the chief of their village just to put a bull or a moratorium on commercial collection of sea cucumbers. And they did. And Palau, again, because of the good leadership, because of the complaints about the spawning aggregations going down, and because of the problems women were having with sea cucumber commercial export, they had the Marine Protection Act of 1994, which protected spawning aggregations when they were most abundant through April all the way through October, but the rest of the year you could catch and export at that time. Then the Protected Areas Network Act of 2003, and I noticed that there's a talk on this Protected Areas Network Act in session 54 at 10:45 this morning. I'll probably go. But the Micronesia Challenge, where 30% of the shoreline marine areas and Shark Haven, they took the whole EEZ, everywhere in Palau you can't hunt sharks. Well, that's a very good start, but they found that the fishermen really liked for a while, and I think I got this story, but it's so long ago, I think I got it from Noah. If he's here, he can contradict me if it's not true. But that they started exporting fish, and they liked going to the grocery store because it was kind of a high status thing, but then started thinking about it. They said, wait, we've got to sell 5 kilograms of fresh fish to buy a little 7-ounce can of canned tuna. It's kind of neat for a while, but that gets old. Another thing is that competition, if you're selling fish commercially, you're losing to the marketing, the transportation and stuff, but if you just sell it locally, you get a bigger price, and the restaurant pays less than for imported fish. And competition with recreational fishing, competition with tourism, competition for all the way across. So, as you know, yesterday, as President Remingusau told you, they said no more export. All of the fish stay here, and all of the resources, I think, stay here. And they set up this total EEZ is non-export, and 80% of it is non-fished, and the 20% of it is fished by Palauans, which is very good. Now, I'm going to cite here that this is another aspect that's really basic biology, is you don't export from coral reefs. Several different aspects I'd like to show you on this. Bruce Hatcher noted that there's tremendous primary productivity, but very little export, which means it's all absorbed net productivity. It's not excess productivity. The only excess productivity is about 2 or 3%, and of that, only about 10% is useful. So you got less in a natural coral reef. 1% is useful export, less than 1%. And another way of looking at it is Scott Nixon showed that coral reefs are very, very high. This is on a log scale or an exponential scale, and so is this. These are both exponential, so this is very much more productive. But most fall along a single line, and they have much greater yield. Well, I think the reason for this is there's about 6 trophic levels here, and so the net production is all taken up. Up here, Ryther said there's only 1.5, and I'd call that 2. I don't know how, it's a science article. But if you've got 2, you've got a lot of that net productivity, you've got excess productivity. And there's other reasons, I'll get to that on the life cycle of the fish. And then Don Kinsey went and got, I think, most measurements himself, but also the literature around the world on coral reefs that the photosynthesis equals respiration, pretty close. So these are three very, very different kind of ways of looking at it, but the bottom line is coral reefs are not made for export, so Palau is doing very well on not exporting from coral reefs. Why is it? In the northwest Hawaiian island, Palavina had his ecopath and really measured all of the various transfers of energy, but he also took the total energy and found out that the net production of benthic algae and zooxanthellae, and below is how much is needed to feed the biomass that's there. And the net productivity is about, well, I mean, the production is 5% less than the consumption. And so obviously they must be taking in food from elsewhere, but they're not exporting. This is another way of looking at it. If they're eating more than's produced, you're not likely to be exporting, you're importing. And part of it is because, and I know there's a real controversy over inverse pyramids, but so what I did is I took the fish from a very, very, very conservative. It's from about 875 surveys in Micronesia, and Harborne is going to tell about these data that I stole that number from tomorrow at 2 o'clock in session 20. So I'll be there too. But if you add up even, these are overfished fish, and then you take the zooplankton and all this, the consumers, you've got an inverted pyramid at any one instant of time because there's much more biomass feeding than there is biomass of the producers. However, if you go only about 2 months, the producers, if you say over this time how much biomass was there, then the producer, this is only an instant in time that you actually have this. As you can see there, though, it's not hard to picture the consumers being more biomass than the producers. Now, this is controversial. I know that they say this is mostly because the fish are curious and they're looking into the camera. So that's why I took the very conservative number. Now, this is where some of the extra energy input might come. It's not phytoplankton, that's only 3%, and remember there's 5%. As Jack Randall discovered, coral reef fish in the Caribbean at least go out into the sea, some of them, grunts go out, and the urchins. And then there's also the zooplankton. People think because the zooplankton comes up at night, it comes up from deep water and then is washed in. But there's been a lot of studies in the 1970s that say even the zooplankton, you count that as part of the biomass of the reef that stays there. One side point I like is even the coral polyp is an inverted triangle because there may be more zooxanthella cells in the coral than there is animal cells, but their animal cells outweigh them by about 5% of the weight is zooxanthellae. At least that's what William Fitt told me casually, so I hope it's okay to quote him on that. But you got 5% of the biomass is producers in a coral polyp, and 95% is animal. Now, it is also the case that corals do take in biomass, and maybe that should be counted as production, but it's animal, so anyway, I think you got the whole coral reef as an inverted pyramid, at least an instant time, and so are the coral polyps themselves. Now, Golbu's data said that over 20 years, the subsistence intake is about 1,200 metric tons per year in Palau. And this is 525 square kilometers, so this is about 2.3 metric tons per square kilometer per year. Now, I go to the literature, and I've got numbers running from 2 to 11 metric tons per kilometer squared per year, so it looks like it's very down on the conservative side. So I think Palau can maintain subsistence, but once again, this is biomass. And it really doesn't mean that much. It's whether they're taking big ones or little ones. And so I'm just showing you that on a scale of biomass, Palau subsistence looks quite plausible. And so I would put them, if they're being a part of the food chain, and this is really an exaggeration because Palauans eat vegetables and other food and imported food, so they easily won't upset the thing too much with subsistence. But the problem is you're not supposed to be exporting, and subsistence with Palauans is okay, but you've got fish being sneaked out of Palau into Asia in the stomachs of, well, about 161,931 stomachs are shipping this food out. And now, to be truthful, they're only there on an average of 6 days apiece, so they're really only adding at any one day about 12.5% of Palau's population. But nonetheless, you're exporting fish, and that's not a good idea. Now, in Hawaii, they had the ali'i, which were the chiefs, would be the only ones who could eat moi, a very easily over-harvested fish because of his life history patterns and other things. And they had a pretty neat system there where fish that were vulnerable to overexploitation were only for the upper class, and women and lower class could only eat things like manini that grew very fast and stuff. It makes a lot of sense, but that would be politically incorrect for me to suggest that right now. But what I could suggest is to feed the tourists pelagic fish, because they are incredibly fast growers. Yellow fin tuna can get 15 kilograms or 30 pounds the first year, 30 kilograms or 60 pounds the second year, and so on, and only lives about 7 years on the average, max about 10. It has a very short life cycle, which means it has very reliable recruitment, and it grows tremendously. So obviously, they're just made to be caught. I mean, they don't live long, so that's a good point. And then the mahi-mahi and the skipjack tuna also grow very fast and live a very short time compared to coral reef fish. Now, coral reef fish are very different, as Howard Choate and Ross Robertson showed in the chapter in Peter Sale's second book. They have a very right angle, or a lot of coral reef fish grow almost to full size and then don't grow anymore, but they live for decades. And in fact, Andrews, DeMartini, and Ebel and others are just publishing. I hope they don't mind, because it's being published, so you can't take this. But the unicorn fish, Naso-unicornis in Hawaii, the males reach sexual maturity their second year, the females their third year, and they reach maximum size their fourth year, and then they live 55 years. Now, this is very different than pelagic fish, because if they live 55 years, they've got to be selected to keep trying. They don't get that much reliably any particular year, and it would be disastrous if you said, oh, let them reproduce once and take them. That's a terrible thing. If the thing lives 55 years, potentially, there's a reason for it. I mean, humans are pretty guaranteed to have children by the time they're 50, and that's when our telomeres start unraveling and all these, well, look, I'm sorry, but there's a reason fish live a long time, and there's a reason that pelagic fish live a short amount of time, because as Lamont C. Cole, I think it was, said, the main thing, if you want to populate an area, is reproduce early, because you're going to go up geometrically compared to an animal that lives longer and reproduces later. And so there's no selection for reproducing later or living longer if you don't have to. And so that's, I think, why it's okay to harvest pelagic fish, because they grow fast and they have reliable recruitment. So you should not harvest or export reef fish, just for subsistence and maybe local sales. Now, why do they grow so fast? Well, they feed differently. On a coral reef, a fish has to catch one that accidentally slipped too far from shelter. The pelagic fish come upon schools of small fish or squid or whatever and gobble up to 25% of their body weight in one feeding. And then there's been a lot of studies, 251 populations were studied by Longhurst and by Murphy to say the fish that lives a long time does not have reliable recruitment. A fish that lives a short amount of time has reliable recruitment. I should say something about the commercial of fishing. When you go fishing, you've got a big ship and it's got to be paid for, and you've also got the commerce of marketing and this kind of thing. Well, something as a long-lived fish and slow-growing, this is an orange Roughy, it reproduces after 23 to 40 years. It reaches maturity, and it can live 149 years. And economically, you can't sustain a boat to go out and get them and just catch enough that you're sustaining the population. So the best thing economically is to liquidate, because your money will grow much faster than those fish will. And the same thing like with sea turtles. If you sell those turtles, those are worth $2,000 a piece. If you sell them, you got $2,000 that is going to start growing by interest. If you wait 20 years for it to lay eggs and then take it, it's depreciated. You've lost too much money. And the same sea cucumbers are very unreliable in their reproduction. I mean, in their successful recruitment. And so it makes sense to liquidate. And another thing I should point out, the Steve Purcell publication here, is the cost, the price that sea cucumbers can bring in Hong Kong. $1,668 per kilogram for this species. That's a high price. This is the average, but even the average is quite good. And this is why it's very good that Palau doesn't export their fish anymore. It's interesting that the economy recognizes this. This article says fishing coral reef species with like the live reef fish trade, the sea cucumbers, giant clams, is a gold rush, because you go and you get it and you leave and you don't expect it to come back. That's economically smart. But they also said that if you don't want to get rich but you want sustainable, then you have to privatize. That's the reason the Magnuson-Stevens Act doesn't work, because it's a tragedy of the commons. You've got, even the economists say, you're not going to do good business unless you privatize. And this is why I think Palau's, the Constitution is very good. It basically privatizes. So these are the reasons that economics works against the biology of long-lived, slow-growing, irregularly recruited animals. The overhead, slow-growing, you just have to privatize. Now, and here's a reason why tourists should get pelagic fish. Don't give them reef fish. Is the coral reef fish grow slow, pelagic fish grow very, very fast. Coral reef fish live a long time, pelagic fish live very shortly. Another reason is that coral reef fish, if you catch it, it's gone for a while anyway, whereas they've got 20% of that area, and if they take fish from that area, the 80%, and perhaps even areas outside the 80%, are going to be replenishing it. So this is much better. But another one, as you all know, is that coral reef fish have an effect on the reef by grazing algae and other ways, whereas pelagic fish are at the effect, that's good English, but they're dependent on nutrients and upwelling. The time they don't have a good recruitment is when you have an El Nino, but their short lifespan will still get you beyond that 1 or 2 years. But if you take all the pelagic fish, you're not going to change upwelling. But if you take the fish from a coral reef, you're going to change the coral reef. So that's a very important difference. Oh, another thing that's about why you should feed pelagic fish to tourists is this area is, well, actually this area is being fed by this area. So if you collect here, this is 600,000 square kilometers. The entire coral reef area is 525. So you got 11,500 times the area of pelagic, and each square kilometer of that 11,500 times is much more productive. So it makes no sense to sell coral reef fishes. So here's what I think. There's 7 billion people. Don't kid yourself. Coral reefs aren't going to help them, and so it's zero. You've got your tourists. I should say, though, we can't go out and say tourists can't eat reef fish, because reef fish might be like drugs or liquor or aphrodisiacs. If you say you can't have it, that's just going to increase the demand for it, so this has all got to be subtle. So anyway, it's best to go for pelagic fish. And then subsistence can be reef fish, but they can also eat pelagic fish. Pelagic fish are not that bad, you know. And so, you know, even maybe make it a socially acceptable thing to eat pelagic fish if you're a resident. And then for very special occasions, and I think they do it, you can maybe take a big humphead wrasse or bumphead parrotfish or grouper for a wedding or a first birth of a child, a big ceremony, that's okay. But one thing, I looked in Google and looked at the various menus, and that actually I'm not afraid of Japanese because they like their sushi, and I think tuna is just fine. And Americans and Australians, we like imported salmon, and we'll take mahi-mahi, and at least I will. And I'm a little worried about China, though, because that's where the live reef fish trade has been mostly. And that's where an awful lot of this exotic foods go. And of the tourists that are coming, of those 161,900 tourists, over half of them, 87,000 are Chinese. And I'm sorry it's already over, but one of the posters here in Monday, number 636 by Wen, was about privatization, the new green. And it's real good about privatizing marine protected areas, and it's, I hope he publishes it. I hope they publish it. I mean, maybe you can look it up somehow, but it's 636 on Monday. But he showed a number of pictures of the reef fish from Taiwan that are being eaten by the Taiwanese, and it's pretty scary. It's all these parrotfish and things like that. So I'm kind of worried about the Chinese, and I'm not, don't mean to be politically incorrect. Anyway, in Palau, there is a feeling that the fish have gone down, but there's still big fish there. And in the protected areas they have here, as you can see, the fish have gone down outside, but they seem to maybe starting a comeback. So I think Palau is doing good. Well, tourism is, there's another big fish. Oh, I'm going back. There's a red one. I pushed the wrong one. Tourism, the reason that President Remengesau got the United Nations Champion of the Earth Award is because he is not hurting his resources, and yet he's building the economy. And a study from some Australians came that the tax revenues from scuba tourism is 24 times higher than the total revenues from the fishing industry before. So that's a smart thing. Also, Noah Ida-ong and President Remengesau are fishermen, but Noah got his degree in economics, and I can see that's right, and you can see what President Remengesau has been doing. Very smart. And tourism is good on Palau. I know most of you have been there, and it's really great. Now, the title here, I'm almost done, says that Palau is a leader on these things, and so I haven't mentioned that yet. Well, one way is, as already mentioned, they had their total EEZ protected from outside, all of their area from outside fishing in 2009. Oh, this is for sharks, though. Only sharks here that's been copied yet, but I hope the rest of the world copies what I just said. But when they started this shark haven, then the next year, a whole bunch of countries did. The next year, even more. It just started an avalanche of places that started it. And then on that Micronesia Challenge, where Palau sets 30% of their coastline marine area as refuge and 20% of their forest, this, I hope, is being done by the other Micronesian countries. So Palau has been a leader. Now, one last thing. You might say, well, it's very easy to have local control over the marine area. If you're on a small island, that's a different culture. We can't do it in the United States. Well, that's not true. There's one really good place. It's the west Kona coast of Hawaii, the Big Island. And there, a group of people set themselves up as a West Hawaii Fishery Management Council. And this included commercial fishermen, recreational fishermen, aquarium fishermen, citizens, just everybody got together and they started making some changes. And just like Palau, another good thing is that the government backed them up. The main state government backed them up. And another thing that's similar to Palau is a lot of it was leadership. Bill Walsh and the chairs of the committee really led this. It isn't, I don't think, just, they had to have somebody bring it all together. But you can see here what this council has done. It's maybe eightfold increased the total catch of fishes. And the total value went up 4 times. And this is the record of the total catch. And one of the things that they did is that and the state backed up as law, is that they made about 35% of the coast as refuge, at least from aquarium fishing. And another thing I might mention, just to bring back the idea of not taking the big ones, is the yellow tang is producing well over, like I think last year it was 280,000 yellow tang. After they've been harvested for decades, they're still producing 280,000. But in addition to the 280,000, the Cephalophilus argus, a student thesis found, is taking about 90,000. So that's almost 400,000 a year are taken off of this little stretch. So they're doing real well. But I think one key thing is that the fishermen don't want the big yellow tang because they're not good in aquarium and they look old. You don't want to look old yellow tang. And the Roy can only take the middle size. So this, as I said, if you take the middle-sized fish, you're going to take a lot more than if you take the big one. Now, that's just my hypothesis. There's no data on that. Another thing that makes the Kona Coast or the West Hawaii Fishery Management Council different from the rest of the United States, but like the rest of the world, is that there's 63 different countries that don't allow spearfishing with scuba. Spearfishing is good, scuba is good, but don't put them together. And the only place in the United States is the Kona Coast of Hawaii. Now, I think there's also one you can't collect abalone with scuba, but this is the only one where you can't go spearfishing with scuba. So by having a local committee manage it with the backing of the government, you can have it in the United States, but it's not likely to spread very fast. But the rest of the world is doing it. Now, just for a review, and we're all done here, the main things that Palau does that's working with and not against the fisheries is they have village-level ownership privatization. This diminishes the tragedy of the common and the gold rush. It really encourages adaptive management of moratoriums, and it's good to have the government support these. The biological meaningful scale of time, you make your moratorium and then study it. You don't study it for 15 years and decide whether you should have a moratorium. And this basically might be a form of the precautionary principle. And then harvest up to the right of the inflection. And this is working with the fisheries, not against it. If you go to the left, like the Magnuson-Stevens Act, you're working against the fisheries. It's self-correcting, large stock, stabilized, native feedback. And then leave the large individuals in the species. Try to take the middle-sized ones. Discourage harvest of herbivores, you all know that. Slow-growing animals, only eat those for special weddings and things like that. No export of natural resources. And also, I think Minister Singabao is putting a cap to some extent on the number of tourists. It's best to encourage tourists that own cameras and they like to take pictures, they fancy stuff, and discourage cattle cars of those that just snorkel around and stand on the coral. And also encourage pelagics in the restaurants and just have local people eating the and so anyway, and then the globalization of the economy is through tourism and service industries, not exporting biomass. And so that's all. And I'm right on the hour. And thank you for sitting through the whole hour. Thank you.